Welcome to the deep dive. We're going deep into the world of large language models today.
Oh, yeah, these AI systems.
The ones that can write and translate.
Even compose music sometimes.
But have you ever thought about what goes into actually building these things?
What's the secret sauce? Right?
Yeah, the secret sauce. And today we're diving deep into a project that is all about that.
A project called RedPajama.
Specifically.
They're versions 1 and 2 datasets.
And I'm really excited because we have some awesome,
really cool research papers.
Yeah, research papers and technical reports to guide our deep dive.
It's going to be a good one.
Now, RedPajama is all about open source, right?
Absolutely.
But that means they're making all of their data and their code
freely available
to anyone.
Anyone.
This is huge for democratizing access to AI development, right?
Yeah, it's like throwing open the doors to the AI world and saying, come on in.
I love that. Okay, so you mentioned some exciting things that we're going to uncover.
Like the sheer scale of RedPajama v2, over 100 trillion tokens?
100 trillion.
That's mind-bogglingly huge.
Wow.
That's a lot of data.
Yeah, I'm hooked already.
Yeah.
But let's start with...
We'll get there.
Okay, we'll get there. Let's start with RedPajama v1.
Yeah, RedPajama v1.
Which was all about recreating the LLaMA dataset.
Right, which was not public, right.
Not exactly public knowledge, no.
Okay, so the team behind RedPajama v1...
They set out on this mission to recreate the mysterious LLaMA dataset.
And they used, what, 7 main sources?
7 main sources, yeah. They used English Common Crawl, C4, GitHub, Wikipedia, books from Project Gutenberg.
Got it. So
ArcSoup and Stack Exchange.
They had all the ingredients.
Yeah, had all the pieces, right. You'd think it'd be pretty straightforward.
Yeah.
But there was a catch.
What was the catch?
The LLaMA paper itself.
Oh.
It was surprisingly vague about how they processed and filtered the data.
So, imagine trying to recreate a world-famous chef's recipe.
Exactly.
But you only have the ingredients list.
You have no instructions.
So the RedPajama team, they had to become data detectives.
Oh, that's a good way to put it.
They had to make some educated guesses along the way.
And they had to really document everything, right?
Meticulously.
To be very transparent.
For example, they knew that the LLaMA team used a classifier to filter out low-quality content from that massive Common Crawl dataset.
Right.
But they didn't know the specifics.
Oh, so they had to, train their own classifier.
They had to train their own and make judgment calls based on limited information.
That's harsh.
It was a challenge.
So RedPajama v1 wasn't just about replicating the data.
It was about way more than that.
It was about transparency, right?
Exactly. Highlighting the importance of transparency.
In AI research.
It was a call for more openness in the field.
I see. So they really wanted to showcase how difficult it is to reproduce these results when the original methods aren't clearly documented.
Absolutely. It's a huge problem in the field.
And even with their best efforts.
Even with all their detective work.
They still had some uncertainties, right?
Some things just weren't clear. Well, the LLaMA paper, for example, it didn't specify which Common Crawl snapshots they used.
Yeah, they had to.
So the RedPajama team had to analyze the data that was available and choose the snapshots they thought were most likely.
So it was just constant detective work.
The constant process of detective work and decision-making.
Okay, so they had this recreated LLaMA dataset, which is RedPajama v1.
Right.
Did they create their own language model with it?
They did.
They did.
They teamed up with Oak Ridge National Lab.
Cool.
And trained 2 models on the Summit supercomputer.
Wow.
One with 3 billion parameters and another with 7 billion.
I didn't know that.
They call these the RedPajama Insight models.
Catchy name.
And get this, they actually had to recompile PyTorch.
Which is?
A machine learning library.
Oh, okay.
Specifically for the Summit supercomputer's architecture.
Wow. That sounds complicated.
It's a lot of work. Talk about dedication.
So did these RedPajama Insight models live up to the original LLaMA?
Well, the 3 billion parameter model actually performed really well, even surpassing other open source models in some benchmarks.
Really?
But the 7 billion parameter model, it lagged behind the original LLaMA v7b.
That's not too surprising.
Given all the challenges they faced.
Right, and the limitations of even a supercomputer?
Exactly. They speculated that the 7b model's performance might have been hampered by having to use a lower precision for calculations.
Because of?
Due to the limitations of the Summit supercomputer's hardware.
So even supercomputers have their limits.
They do.
But wait, didn't you say that one of their models did outperform other open source models on certain tasks?
I did. The RedPajama Insight 7b Instruct model, which they fine-tuned for following instructions, it actually did outperform some leading open source models on certain few-shot learning tasks.
That's impressive. So even with those limitations.
It created something really valuable.
So where does RedPajama v2 fit into all of this?
RedPajama v2, it takes a totally different approach. Instead of trying to recreate a specific data set, they shifted their focus to creating a massive, versatile resource built primarily from web data.
And they included those quality signals you mentioned, right?
Exactly. They realized that instead of pre-filtering the data, they could provide users with these signals, basically metadata that acts like labels.
Got it.
To help them create their own custom high-quality subsets.
So it's like they gave everyone the keys to the kingdom.
Yeah, and said, here's all the data.
And here are the tools to make it work for you.
You got it.
So they processed a massive amount of data.
From Common Crawl, spanning 84 monthly snapshots between 2014 and 2023.
84 monthly snapshots.
84, yeah.
Why so many?
It's all about versatility, giving researchers incredible flexibility to focus on specific periods, compare how language changes over time, or even train models on data from different years to see how that affects performance.
It's like having a time machine for language data.
It is.
I like that. That's really cool.
It's pretty neat.
Okay, so we've got this massive data set, but what about those quality signals? Can you give me some concrete examples of what kind of metadata they're providing?
Absolutely. They've got a whole bunch grouped into 5 categories: natural language, repetitiveness, content-based, ML heuristics, and deduplication.
Okay, that's a lot to unpack.
We can do it.
Let's start with natural language signals. What are those?
Natural language signals, these help identify text that doesn't really resemble natural human language.
Like what?
Think like code snippets, or those annoying website menus that sometimes end up in data sets?
I've seen those.
Yeah, and one example is the fraction of words in all caps.
Okay.
Natural language doesn't usually have a ton of all caps words.
Right.
So a high percentage could indicate something's off.
So they're basically teaching the AI to recognize what real human language looks like.
Yeah, exactly.
What about repetitiveness?
That one seems pretty self-explanatory.
It does, but
Too much repetition usually signals low-quality content. So they calculate things like the fraction of characters that are part of repeated phrases.
that makes sense. They're filtering out the noise to make sure the AI is learning from the good stuff.
Exactly, the meaningful text.
Okay, what about content-based signals? What are they looking for there?
These signals are all about ensuring the data set is usable and doesn't contain problematic material.
Oh, okay.
So they've incorporated techniques to identify and remove duplicate documents, which helps improve training efficiency and prevents the model from, overfitting on the same information.
So it's like they're cleaning up the data and organizing it so the AI can learn effectively.
Exactly.
And what about those ML heuristics? That sounds pretty complex.
It is interesting. Instead of relying solely on hard-coded rules, they actually use machine learning models to evaluate the quality of the documents.
Okay.
One method they use is fast text classifiers,
And those are...
which compare the text to high-quality reference domains like Wikipedia.
So it's like using one AI to judge the quality of data for another AI.
That's a great way to put it.
That's pretty meta.
It is.
Okay, what about the last category, deduplication?
These signals ensure they're not training the model on the same information repeatedly.
Right.
They use techniques like min-hash and Bloom filters to identify and remove duplicate documents.
Got it. So with all these quality signals, it sounds like RedPajama v2 is really empowering users to create custom data sets based on their own, specific needs and goals.
You got it. They're not just providing data, they're providing a framework for responsible and tailored AI development.
This is all incredibly fascinating. It's clear that RedPajama is really pushing the boundaries of open source AI development. But before we go any further, let's take a quick pause and come back to explore what they actually did with this massive data set.
Sounds good.
All right, we'll be right back.
After the break. Welcome back.
So before the break, we were talking about RedPajama v2 and how they're giving researchers this massive data set and a set of tools.
Like a toolbox.
Yeah, to create their own custom subset.
Tailored to their needs.
But did they actually train any large language models on the full RedPajama v2 data set themselves?
That's a great question, and that's where things get even more interesting.
Oh.
So they actually focused on providing the raw data and the tools for customization.
Okay.
But they didn't train models on the full 123.7 trillion tokens.
And why is that?
Well, that would be a computationally massive undertaking, even with the most powerful computers available.
123.7 trillion tokens.
It's a lot.
Yeah, that's astronomical. So
Yeah.
even Google might have some trouble training a model on all of that.
You're not wrong.
So they didn't train any models on the whole thing?
Not on the full data set, no.
But that doesn't mean they didn't put the data set to the test.
Of course not. They did plenty of testing.
Like what?
Remember those ablation studies we mentioned earlier?
Yeah, they're experimenting with different
Recipes.
recipes to see how each affected the final product.
Which in this case is the trained language model.
Exactly. So they trained models with 468 million and 1.6 billion parameters.
Relatively small.
Yeah.
Compared to
some of the giants out there.
Right, but still.
Large enough to draw meaningful conclusions.
So what did they do? They just let these models loose on the internet and see what happened.
Not quite. They used a diverse set of benchmarks to evaluate how well these models performed across different tasks.
Right.
Like question answering, summarizing text, even translating languages.
Okay, and what did they find? Did those quality signals actually make a difference?
In many cases, yes.
How so?
For example, applying the gopher rules.
Remind me what those are again?
It's a set of filtering heuristics developed for another large language model.
Right.
And those generally led to improved performance across several benchmarks.
Interesting.
Especially when combined with removing duplicate documents.
So it seems like filtering out the lower quality data leads to models that can generalize better.
To a wider range of tasks, yeah.
Okay, that makes sense.
But there was one interesting finding that might surprise you.
Okay, I'm intrigued. Tell me. They found that the model trained on the raw, unfiltered RedPajama v2 dataset actually achieved the lowest perplexity on the LLaMA dataset.
Wait, really?
Yeah.
That's kind of counterintuitive.
It is a little bit.
I would have thought that cleaner data would always lead to better performance.
You'd think so, right?
Can you remind me what perplexity is again?
Yeah, so perplexity is a way to measure how well a language model can predict the next word in a sequence.
Okay.
The lower the perplexity, the better the model is at predicting what comes next.
Makes sense.
Think of it as a measure of how surprised the model is.
Okay.
A lower perplexity means the model is less surprised, like a good storyteller who keeps you engaged and guessing what's coming next.
I like that analogy. So a lower perplexity means the model is better at understanding the flow of language.
Exactly.
But why would the unfiltered dataset perform better in this case?
Well, the LLaMA dataset is known for its wide range of topics and writing styles. Very diverse.
That means?
This result suggests that filtering out data, even if it's considered lower quality, might actually remove some of that diversity, which can hurt performance on tasks that require a broader knowledge base.
So it's like a trade-off.
Right.
Sometimes a little bit of messiness in the data can actually be a good thing.
Sometimes, yeah.
Huh. Interesting. This all makes me think about the bigger picture.
Yeah. Where does this fit in? Right.
Right. What does RedPajama mean for the future of large language models?
Well, I think RedPajama is a game changer for open and transparent AI development.
How so?
By providing a massive, high-quality data set that anyone can use. They're fostering a community of researchers and developers who can build on each other's work and push the boundaries of what's possible.
It's like they've created this incredible playground for AI innovation.
I like that.
Where anyone can come in, experiment, and contribute their ideas.
That's a great way to put it.
And that kind of open collaboration is essential for ensuring that the future of AI is shaped by a diverse range of voices.
Not just those within large tech companies.
Right, exactly. So it's more inclusive.
Absolutely.
Okay, this all sounds very positive, but I have to ask, are there any potential downsides to this?
Downsides?
To this open approach? I mean, we're talking about a data set scraped from the web.
Right.
And the web can be a pretty messy place.
That's a valid point.
Yeah.
There's always the potential for biases and inaccuracies.
To creep into the data.
Especially one as massive as RedPajama.
Yeah, that's a good point.
It's something that researchers need to be constantly aware of.
And actively work to mitigate.
Exactly.
So it's not a magic solution.
No.
But it's definitely a huge step in the right direction.
I think so.
Yeah, because it provides the resources and encourages the responsible development of large language models, which is something we should all be excited about.
Absolutely.
So they didn't train models on the full RedPajama v2.
Right.
But they did release those smaller scale models.
Trained on various subsets, yeah.
What can people actually do with those?
Well, those smaller models are available for anyone to download and experiment with.
Oh.
And they even provide detailed descriptions of their filtering configurations.
Yeah.
So others can replicate their work or explore different variations.
That's amazing. So it really lowers the barrier to entry for AI research.
For sure.
And gives people who might not have access to, huge computing resources a chance to actually get involved.
Exactly, democratizing access and fostering innovation.
I like that. Okay, so we talked about the importance of open source data sets. We've explored RedPajama v1 and Nash v2.
The ins and outs.
Yeah, and we even touched on the potential impact of this project on the future of AI.
It's a big one.
But there's one more fascinating aspect of RedPajama v2 that we need to discuss.
Oh, there's more.
Yeah, we haven't even gotten to the best part yet.
Okay, I'm ready. Tell me.
So remember how they included data spanning multiple years?
The 84 monthly snapshots of Common Crawl.
Exactly. That temporal dimension opens up so many possibilities for research.
It's like a time machine.
It is. They can study how language evolves over time, how trends emerge, and how the way we communicate reflects broader changes in society.
Wow, we can track the emergence of new slang.
Oh yeah, and how the sentiment towards certain topics changes.
And even how the use of emojis has evolved.
Think about it. All the insights we could glean from this data, it's incredible.
Yeah, we could track the spread of new ideas.
Analyze online community.
Even study the impact of major events.
But wait, we've talked about the quality signals, the ablation studies, even the time machine aspect.
What's missing?
What are the actual insights that can be gleaned from this data? How can researchers use this to study the evolution of language?
That's a great question, and that's where things get really exciting.
Okay, I'm ready.
We're talking about being able to track how the very fabric of language changes over time.
So not just new words and slang, but deeper shifts.
Deeper shifts, exactly.
Wow!
Imagine being able to map how grammatical structures evolve.
Or how the topics we discuss online shift.
Even how the sentiment towards certain ideas changes. It's like having a linguistic fossil record.
Allowing us to see the evolution of language.
In action.
That's amazing. So we could literally watch how language adapts and changes in response to the world around us.
Precisely.
And this kind of analysis could have implications beyond just linguistics, right?
Oh, absolutely. Think marketing, journalism, political science.
Oh, I see what you mean. Marketers could use this data to understand how language trends influence consumer behavior.
Journalists could track the spread of misinformation.
Or identify emerging narratives. And political scientists could analyze how public discourse shapes political opinions.
Exactly. The applications are vast.
And RedPajama v2 provides the perfect platform for these kinds of explorations.
With its unprecedented scale and temporal depth.
Right, but this also has significant implications for understanding bias in AI, doesn't it?
Bias.
Yeah, if we can see how biases are reflected in language over time, maybe we can develop more effective ways to mitigate them.
And the data sets used to train large language models?
Exactly.
You're absolutely right.
It's about making sure the technology we create reflects the best of humanity, not its flaws.
Well said.
It's a huge responsibility.
It is.
But one that RedPajama is helping us to shoulder.
By providing open access to this incredible data set.
They are empowering a global community to work together towards a more inclusive and ethically minded future for AI. That's inspiring.
It is very inspiring.
I am absolutely buzzing after this deep dive.
Me too. It's fascinating stuff.
The sheer scale of RedPajama v2 is mind-boggling.
It is.
But it's the potential for research and ethical development that I'm most excited about.
It's a project that's pushing the boundaries.
It's just the beginning.
Who knows what we'll discover?
What amazing applications will emerge from this data set in the years to come?
It's exciting to think about.
So that brings us to the end of this deep dive. But before we go, I want to leave you with one final thought. So we've explored the potential of RedPajama v2, how it can help us understand how language changes over time.
It really is like a time machine for language.
But what if we went a step further? What if we use this data set to study not just how we communicate, but how we think?
How we think.
Yeah, what if we could trace the evolution of ideas?
Whoa, that's a big one.
I know, right? It's like, how do we even define what it means for an AI to grasp an idea?
That's a question philosophers have been debating for centuries.
Exactly, but I think RedPajama v2 gives us a way to explore that.
How so?
Imagine being able to track how certain concepts emerge.
In the data set.
Yeah, how they spread, connect with other ideas, and shape how we think about the world.
So we could track scientific thought.
The rise and fall of political ideologies.
Even the evolution of social movements.
It'd be like having a window into the collective consciousness of humanity.
Wow, we could see how ideas gain traction.
How they influence other concepts.
And how they shape our understanding of ourselves and the world.
It's like using RedPajama v2 as a massive cultural observatory.
Observing the flow of ideas through society, something we've never been able to do before.
It's like fast-forwarding and rewinding through history.
Seeing how ideas have shaped us.
And this kind of analysis could impact so many fields.
Like what?
history,
sociology,
even philosophy.
historians could gain new perspectives.
Sociologists could study how ideas spread and influence behavior.
And philosophers could explore the very nature of knowledge.
It's amazing to think we might be on the cusp of understanding human thought in a completely new way.
All thanks to this dataset.
It's really a testament to open source collaboration
And the potential of AI.
to help us understand ourselves.
And the world.
This deep dive into RedPajama has been so inspiring.
It's amazing work they're doing.
It's clear this project is more than just data. It's a catalyst for discovery
A tool for understanding.
and a beacon of hope for a more open and collaborative future.
In AI development.
I couldn't agree more. It's an exciting time to be involved in this field, and I can't wait to see what emerges from RedPajama in the future.
Me too. It feels like we're just scratching the surface.
So, to our listener, we encourage you to dive into RedPajama yourself. Explore the data.
Ask your own questions.
See what you can find.
You might just make the next big discovery.
And remember, this is just the beginning.
The future of AI is being written right now.
And with projects like RedPajama leading the way.
It's a future full of potential.
For understanding, innovation, and positive change.
Couldn't have said it better myself.
Thank you for joining us on this journey into the world of RedPajama.
It's been a pleasure.
Until next time, keep exploring, keep learning.
And keep diving deep.